Welcome back, dear students. I hope you have attempted to do certain problems which I had given for practice in the previous video, and you have got used to the three different types of finding out correlation coefficient, the three formulae. So here again we shall focus on some more problems on correlation coefficient, but this time the data in these problems is not as explicitly given as in the previous set of problems, but the required summation totals are specified in the problem and we are asked to compute the correlation coefficient. So we shall focus on two types of such problems in this particular video. This is a recall of the three formulae which we have already learned and also learned how to apply: the direct method, the actual mean method, and the assumed mean method. We shall apply one of these in our problems now. So this slide is posted here. It's only for a quick recall of what we have learned. So let's begin with question number 1, which reads this way. A computer, while calculating the correlation coefficient between the two variables x and y from 25 pairs of observations, obtained the following results. So we are given 25 pairs of values. And as I told you, the data is not explicitly given here, but the sum totals are directly specified to us. So we have this summation of all the values of x, sigma y, sigma x square, sigma y square, sigma xy. So all the values have been specified. Totals are given to us. It was later found that two pairs were wrongly taken as 6, 14 and 8, 6, while the correct values are 8, 12 and 6, 8. So find the correct correlation coefficient. Now, if we had wondered if this data was given to us, it was only direct substitution to get the value of rho. But the question slightly deviated here. It says that the two pairs that were given to us were wrongly taken as. So the wrong values that were taken, one x and y values. So one value was 6 and the y value is 14. The second point was x value is 8 and y value is 6. So the x values were considered as 6 and 8. Y values were considered as 14 and 6, whereas the correct values that had to be actually calculated were 8, 12. So x is 8 and y is 12, and x is 6 and y is 8. So basing on what is given to us, we have now written the wrong values and the correct values. Using the wrong values only, this data has been calculated. So if we have to find the correct correlation coefficient, that means all the corrections in these data, in the given data, has to be done. So let us start off by starting with the first summation value given to us, sigma x. Now sigma x represents the total of all x values. So total of all x values is given to be 125, but the wrong x values were 6 and 8. So when I say wrong values were 6 and 8, that means we need to subtract this from the total which is 125. So we subtract the wrong x value. So I write it as minus 6, minus 8, and we have to make a correction. So now correct or include the correct x values, which is 8 and 6. It so happens that the values are the same. So you are adding plus 8 and plus 6. So what is happening here? You are subtracting and adding 6, you are subtracting and adding 8. So it is getting cancelled. So 125 remains as it is. So the new sigma x is also 125. So these are all the new values. Similarly, sigma y. Now move to the next summation value, sigma y. The total is given to be 100. Now the wrong values have to be subtracted, that is 14 and 6 are to be subtracted. So we write minus 14, minus 6. And now we include the correct values, which is 12 and 8. So we include 12, that is adding 8, 12 and adding 8. So since the total of 14, 6 and 12 and 8 is 20, So it is like remains again new y value, summation y value remains to be 100, no change. Moving to the next summation value, it is sigma x square. Sigma x square is given to be 650. So we write that 650. What should we subtract? We should subtract the squared wrong values of x. So squared, we are talking about x square. So we are going to square the wrong values. So it will be 6 square and 8 square. So that we have subtracted. And now you have to add the squared correct values. So that is 8 and 6. So you're adding 8 square and 6 square. Again, so happens it gets cancelled. So that 650 remains as it is. Coming to sigma y square now. Sigma y square is 460. You are subtracting the squared y values, which were wrong. So it is you're going to subtract 14 square, 6 square, because you're calculating the squared values, and you are adding 12 square and 8 square, which are the correct values, and that changes here. So the new y sigma y square value is becoming 436. Looking at sigma xy. Sigma xy is given to be 508. So now you have to subtract the product of x and y. So this is the wrong values, which is 6 and 14 was considered. So you subtract 6 into 14. You subtract 8 into 6. So that's what you've done here. Then you add the product 8 into 12. That's here, and you add 6 into 8 because they are the correct values. So new sigma xy is given to be 520. So this is how the problem has been created. Very beautiful it is. So the values given to us has included the wrong values, and it's also correct values are given. So what we need to do is, from the totals given, we subtract the wrong values and we include the correct values. So you remove the wrong values and you include the correct values, so that you get the final corrected total summation values. Now all the values are obtained. Now we just have to substitute it in the formula. Which formula we shall substitute? The diet, because it's all in terms of x and y, so there is no mean, nothing here, and therefore we shall go in for the direct formula, substitute all the values and get the result of rho. Let's see how. So now we have written the formula for rho, the direct formula. We have substituted all the correct values. You see, all the correct values are substituted here, like it is 520, 650. Some of them there is no change, but some there is a small slight change, and thereby simplifying it, we get the correct correlation coefficient is 0.6667. So this is a problem where the exclusive or explicit data is not given, but there are certain corrections which have been made. Some errors have been committed, corrections have been made, so we had to incorporate those corrections and rearrange again the summation values, and then finally substitute it in the direct formula. So this type of problem is the first one. Let us look at the second type of problem in my next slide. Let's read the second question now. Find the coefficient of correlation given n is 12. Again, we do not have explicit data. Sigma x minus 8 the whole square is given. Then similarly, sigma y minus 10 the whole square is given, sigma x is given, sigma y is given, sigma the product of x minus 8 and y minus 10 is given. So this gives us a slight hint. When we were talking about assumed mean, we wrote it as sigma x minus a the whole square, right? We calculated small x to be equal to capital X minus a. We are not sure whether this 8 and 10 are the actual mean or the assumed mean. Since there is no clarity on that, we take it to be the assumed mean. The assumed mean of capital X and capital Y are taken to be 8 and 10. So what is our substitution by our general theory? We take x cap small x to be, or we write it in terms of dx, not even x. We write dx to be x minus a and dy to be y minus b, where a here is 8 and b here is 10. So we simplify the given data by making this substitution. That's why I've written here, let dx is equal to x minus 8 and dy equal to y minus 10. So if I have to use it in my assumed mean formula, then I need to know the values of sigma dx. I need to know what is sigma dy. I need to know what is sigma dx square, sigma dy square, and sigma dx dy, isn't it? I need to know all these values. So let's see from the assumption we are making. So we have put dx is equal to x minus 8, dy is equal to y minus 10 because these are deviations. So how do I rewrite this particular expression? Sigma x minus 8 the whole square is equal to 150. Because x minus 8 is equal to dx, it will become sigma dx square, because I have a square, is equal to 150. Similarly, look at this expression, sigma y minus 10 the whole square equal to 200. Since y minus 10 is dy, it will become sigma dy square equal to 200. Look at the last one, sigma x minus 8 into y minus 10 is 50, x minus 8 is dx, y minus 10 is dy. I have sigma dx dy is 50. So of which what all do we know now? We know sigma dx square, so this is known. We know sigma dy square, we know sigma dx dy. So all the three are known. So what is yet to be found? What is sigma dx and what is sigma dy? So what is given to us? Instead of sigma dx, what is given to us in the problem? Sigma x is 120. We make use of that. So I've started with sigma x is 120. But what is my x from my substitution? If dx is equal to x minus 8, can you all agree that x equal to dx plus 8? Just a simplification. So yes, indeed. So therefore, instead of x, I write it as dx plus 8. So sigma of dx plus 8 is equal to 120. Now, applying the summation to every term in the bracket, it will become sigma dx, that's the first term, plus sigma 8 is equal to 120. So sigma dx is kept as it is. What do you mean by sigma 8? When I say sigma 8, that means how many times I have here? 12 values I have. That means I am adding 8 12 times, because I'm having 12 observations. So I'm adding 8 12 times, which implies sigma 8 will become n times 8, or it becomes 12 times 8. Correct. Sigma dx is the first term which will be kept as it is. When I say sigma 8, that means I am adding 8 n number of times. But what is n in my problem, as it is given to me here as 12? What does sigma 8 means? You are adding a number 8 12 times. So when you add 8 12 times, the sum becomes 8 into 12. So when you take that to the right side and subtract it from 120, sigma dx therefore becomes 24. So we have now calculated sigma dx also. So this is also found. Using what? Sigma x is 120. Now similarly, take up sigma y is 130. So I start with sigma y is 130 here. But what is y, capital Y from here? Capital Y is equal to dy plus 10. So I use that here. Instead of y, I write it as dy plus 10. Then I apply the sigma to every term. So it becomes sigma dy plus sigma 10. What does sigma 10 means? You are adding 10 how many times? N times. And that is nothing but 12 times in our problem, because n is 12. So when you are adding 10 12 times, so it becomes 120. So 130 minus 120, and thereby you are getting sigma dy is equal to 10. So you have now calculated sigma dy also. All the values are obtained from the given data, and we shall now use the assumed mean formula to calculate the value of rho. So we have now taken the formula for the assumed mean, and then we substitute all the values and get the value of rho to be 0.2150. Kindly Remind yourself that the row value should always lie between -1 and +1. It cannot be beyond 1 or before -1. So this is the second type of the problem that we have when the data is not explicitly given. So since you have written your capital X minus 8 and Y minus 10, we don't assume 8 and 10 to be the actual mean since there is no mention about it, and we take it to be the assumed mean, and therefore we call x minus 8 as dx, y minus 10 as dy, and proceed the problem as explained in my previous slide. Now these are the two very important types of problems that we have when the data is not explicitly given. We shall now take it forward. I can give you some problems for practice. You may try it out. So let me show that to you in my next slide. So based on the problem one that we did, this is a similar one where corrections are to be made. So these are the wrong values taken up, and these are the correct values. Similarly, the wrong values, and these are the correct values. So kindly practice these two problems based on problem number one that we explained. And these two are the problems where we did in problem number 2 by using the assumed mean method. So we take x minus 10 as dx here, y minus 15 as dy. Similarly, x minus 35 as dx here, y minus 31 as dy. Apply the assumed mean formula, calculate sigma dx, sigma dy. That's where the main problem lies. And then, of course, the substitution in the formula to get the value of rho. So these are some of the standard problems when the values are not explicitly given, but the sum totals are directly given with certain corrections to be made. I hope you will practice all the 4 problems and confirm the answers. If there's any discrepancy in the answers, kindly let me know. So thank you once again. We shall meet with the next topic in my next video.